Okay, so here's a standard inverting amplifier, and I have written here for the class to build a non-inverting amplifier. If you have time, you can do it. It's okay if you don't. But so you can see here, like right now I have about 0 volts here, and this is also about 0 volts, and I have you know, for all practical purposes, 0 volts on the output. So if I increase this voltage, the negative voltage here, or the inverting input, you'll see that it's going to change up here. Okay, so you'll see the voltage changing up here. Okay, and you will also notice the voltage and the current changing here. Right now, these two are almost zero. Okay, I can bring it closer to that, but for all practical purposes, it's zero. And this voltage is also zero. I mean, negative 4 millivolts and 4 microamps. There's no current actually for all practical purposes. Okay. So what I'm going to do is this a variable power supply. I'll just increase the voltage a little bit. So now I have 7 millivolts here. Remember, I had 1. Now I'm going to increase it to 7 millivolts, and now the negative input is greater than the positive input, so the output becomes minus 14 volts, or minus this one. It equals this number here. Okay. So, and also notice that if I keep increasing this, so this, I don't know how much this goes up to, but let's say I put 7 volts, nothing happens here. So it won't increase. If I put 300 volts here, probably would blow up this thing. But let's say I put 25 volts here. The output will not go to 25 volts. So you need to kind of remember that the output will never become greater than this number or this number. Okay, so 7.5 volts, I'll drop it to 0 volts. It becomes that. The moment this number becomes larger, the output becomes larger. So right now I have I don't know what, some microvolts value, and I got 5 volts. So just increase this just a notch. 1 volt. So this becomes really close to this number here. Okay, and then as I increase this, obviously enough, it just jumps right to this number here. Now this very small change that I'm getting here is because there is negative feedback. Okay. So I dropped it. Let's see, I have 0.5 volts. So I have negative 5 volts. But the moment I start increasing it, this number starts jumping. Okay. So 948 microvolts, I get 10 volts output here. And 1.5 volts, I get 14 volts. So if I increase this to 10 volts, it's going to be this number. And remember again, if I make this number, let me just do that. I can do that real quickly. I'll make it 25. So if I have 25 volts in here, I won't go to 25 volts. It'll just stay at this number. It's going to equal this number, or it's going to equal this number. Okay. So quite often people make that mistake thinking that if I put, so in this case I have, if this is 0 volts, then the differential input is 21 volts, that the output will go to 21 volts. It won't. It'll stay at either this number, well in this case it's because it's an inverting input, it'll equal this number here, just minus 15 volts. That's what you're getting here. And I get 14 milliamps or something. So that's because of this current going through here. I can make it larger or smaller, obviously enough, by changing this resistance. Okay. So that's the inverting amplifier. If you want to build a non-inverting amplifier, all you have to do is to, instead of doing it here, just bring that to this input here, to the non-inverting input, and make this equal to ground. And you'll get the opposite values. So you'll get plus 14 volts instead of minus, well, plus 15 volts instead of minus 50 volts. All right. So that's the inverting amplifier. The other one I wanted to do was the differential amplifier. So here's one that I have a differential amplifier. It amplifies the difference between these two. Okay. So in this case, let me see if I can bring this back close to 9 volts, 9 volts. I have nothing. That means both of these are almost 0 volts. Let's see if this will settle down to what the number is. So realize that even though this says 9 volts and this says 9 volts, they are not exactly the same. That's why I'm getting this very small number. So if I see if I can change that just a little bit. So I want to go in the other direction. So now I have, let's let that settle down. So this is the inverting input is 8.5 volts. We'll make that 8 volts. Make this 9 volts. I'll wait till this settles down. So this is 9 volts and this is 8 volts. So that means this non-inverting input, the non-inverting input down here is greater than this one. So the output will swing to this 12 volts plus, which is this one here. Okay. Now if I make this inverting input larger, so that now the inverting input it's 10, it's set at, let me let that settle down. So that's 10 volts, right? That's 10 volts. This is 9 volts. So the inverting input is greater than the non-inverting. So the output swings to minus 12 volts, which is this one right here. Okay. So that's a basic differential amplifier. Just amplifies the difference between the two. Okay, so this is the op-amp comparator circuit that we looked at before this. So let me turn this power on. And so right now it's connected to ground. And the reason why I have this huge 1 mega ohm resistor here is that when you connect these numbers, if you don't have this resistor, then you short circuit this input. So it's important to have this resistor here. So right now I have 1.3 volts in the negative or the inverting input and almost 0 volts on the non-inverting, which means that the inverting input, this one, the inverting input is greater than the non-inverting input. That's why this output goes to minus 14 volts. There's minus 14 volts that when it goes to this transistor, well actually it doesn't go to the transistor because the negative 14 volts it will forward bias this diode and it will conduct to ground. And this big hefty 100K resistor, that's what it's doing. It's limiting the current so that you don't load this device down too much. So less current will go through it. Remember, we are not worried about the current in these cases, but not so much. Okay. So in this case, this diode is forward biased, so nothing comes to the transistor. In any case, negative 15 volts at this transistor, this NPN transistor, so if you put a positive to the base, which is a P, this transistor will be reverse biased, so nothing will, this will act like an open switch, which is exactly what it's doing because this LED stays off. Okay. Now I'll put this first connect, and you'll see how cumbersome it is to put these wires one at a time like that. Okay. So I have 522 millivolts, and I have 1.3 volts, whatever here. And so output, nothing happens. This doesn't change. Okay. So I have to take this one wire off at a time. Let me double check those numbers also. Okay, that's correct. Right, so I'm going to take this out, and I'll go to this connection here. This is really labor intense operation. So I have 1.4 volts, 1.0 volts, and yet the non-inverting input is greater than the inverting input. So this is 1 volt, this is 1.3 or 1.4 volts. So that's why it stays at negative 14 volts. Okay. I turn the power off. Well, this is getting cumbersome. Okay. Put it to here, and let's see what happens. So now I have 1.4 volts, which means that non-inverting is greater than the inverting. So the this diode is reverse biased because it's 14 volts plus. Transistor is forward biased, it's conducting, and the light comes on. Voila. Alright, so if I had to go back to these things, I'm not going to be doing that. That takes forever. So there is an easier way to do it, and that's the lab that I wanted to do. Instead of putting these switches back again, instead of putting these wires one at a time like this, what I want you to do is to put this device here. See, this is a dip switch, dip standing for dual inline package, and you'll notice that this comes in different configurations. So obviously enough, in this case you want to do 1, 2, 3, 4, 5, 6, 7. So I don't think there's a 7, but there's, I think, an 8. 6 won't do, you need the 7. So be careful, we need to watch this dot. That shows switch number 1, which is A or 1. Oh, it's 1. So that's switch number 1. You see how I'm just pressing the number 1 key, and how that's turning on and off. But I haven't turned the power supply on, that's why this LED is not coming on. And this part shows the output. This dot here shows the output. So I just built this circuit to show you how I want you to do this, is to take this, a switch, not this switch, but a switch like this, and put it in this circuit so that you can switch these things one at a time like that, instead of that cumbersome thing of what I was showing you with one wire at a time. So in this case, this switch, what it does is, let me turn the power on, and so both of these switches are off. And the purpose of this 1 mega ohm resistor is because these two outputs are shorted. Just give me 1 second. My son brought lunch, dinner, something like that. I'm going to see what he has brought. Hold on. Whoop, you need to knock the camera off. Ooh, colors.
Sorry, I didn't mean to be loud.
It's all right.
You want some?
What?
There's nothing in there.
I'll show you the class. Look, lunch, dinner. You see? Colors. Okay. Moving right along. So this 1 mega ohm resistor, why I put that is, if you don't do that, you'll short circuit this to ground. Okay. And now what I'm going to do is I turn the power on, turn this switch on, so that means the output is 0. You see, turn it on, it's just connected to this, right? So it's connected to this, 0 volts, the LED is off. Okay, let me turn that off and turn the switch 1 on and the LED comes on. Okay, so switch 1, LED comes on, that goes to 5 volts, well 2 volts, that's because of this voltage drop right here. Okay, and that turns the LED on. Now, the reason again why I have this is that when you turn both of these switches on, if I don't have that, I will kill this output. Well, not kill, but short circuit it. Because I have this 1 mega ohm resistor, this didn't change. If I did not, it'll you have a closed circuit like this, right, to ground. This circuit will never turn on if you turn both on. You need to be able to do that with this big circuit to have switches. Okay? So that's your assignment, to essentially replicate this switch that I have here in here, so that you don't have to do one wire at a time, switching back and forth. Okay, that's your lab, and now you'll know how to use a dip switch too. Good things that you learn. All right.